Hey y'all, welcome to the rolling update tutorial. In today's session, we are going to go through a rolling update in Kubernetes. We're going to touch on the topics of deployments, replica sets, and rolling updates. As always, I will include the manifest and the commands that I'm running, so you can customize all of this, do it on your own. It'll be in the description. Without further ado, let's get started. We will kick things off, of course, with talking about what is a rolling update. It's a really good thing to know about because it's actually the default strategy for Kubernetes. So even if you don't know that you're doing this, it's what's going on under the hood. As simple as possible, a rolling update is where pods are updated one by one. When it reaches the desired state, so the new version you want to deploy, then we've done it. It's all rolled through. And when we say roll them, it means that Kubernetes replica set takes one pod down, says no more traffic, then it spins up another one to take its place. So it runs through the pods and does that until everything's done. And because it does roll through them, it allows you to run upgrades with no downtime. We've talked a lot about deployments before, we've built them, played around with them, but something that's going to be important when understanding what's happening with rolling updates is replica sets, specifically how they work with deployments. So let's get into that. So first off, what is a replica set? Let's pull up the docs. A replica set's purpose, as we can read here, is to maintain a stable set of replica pods running at any given time. As such, it's often used to guarantee the availability of a specified number of identical pods. How it works is really it's given some ground rules. So the pods it should be looking after, how many it should be maintaining, and then it creates and deletes the pods to make sure we have the desired number. You can think of it as someone hosting an award show and needing to make sure that I have all the seats on camera filled in. Someone got sick, boom, fill that seat. Someone's sleepy, can't be seen on camera, you're going home, see you later, let's get some fresh legs in here. And what's ultimately going on is there's a metadata field called owner reference on the pods, and it clarifies which resource the current object is owned by. You can think of it as like a collar on a dog with the name and number. There's no doubt about the owner there. And then the replica set uses the selectors that are set up, and if the replica set finds a stray pod that matches their selector, it'll immediately acquire or adopt it. Is the replica set the same as a deployment, you might be asking? It's close, but no. The difference is exactly what we're going to cover. When we create a deployment, it creates a replica set and just offloads the whole counting pods thing to that. Great leaders know how to delegate, and that's what a deployment does. The replica set does one thing, it does it really well. Each replica set's actually in charge of just one type of pod, so if I create a new version update, it won't be able to have both. Let's go ahead and see this in practice. Let's start by getting a cluster up. We are going to use Minikube, and we're going to pin the version for Kubernetes at 1.23.3. So here's the command. I'll put it in the comments and I'll see you on the other side. So I have a cluster up. I'll go ahead and prove it with the git nodes. You can see that it's ready. And I went ahead and actually created a new directory for rolling deployments also. So you can see I have rolling updates. I have a service that's actually the same one as down here in the demo prod. So just a standard load balancer listening on port 80. And then I created a deployment, so we're going to go ahead and make some updates there. But before we get into that and the manifest, I want to clarify some things. If you were listening when I was describing rolling updates, you might have noticed that I described a situation where a pod goes down and another goes up to replace it, and then you also might have started to think about some what ifs. What if there's a situation where we need more pods up, or we don't want to go below a certain number? So let's think ahead, and maybe we can bake that into the deployment actually, so there's no issues there, and we can have, we can ensure that we have no downtime. I'm going to pull up the API docs side by side with the deployment, and we'll talk about what we can do. All right, so I have the deployment over here, and then I have the API docs over here. A couple updates before we actually get into the updates that we're making. I did add some metadata, so I have version 1.1.0 here. I did change the replicas to 5 to make some of the percentages easier. You'll see what I mean. And then I had some metadata down here, and I'm going to change this to V1. This is the first version of our app. But over here, this is the interesting piece I want to talk about. So let's go down to strategy. You can see there's a deployment strategy stanza under the spec, and we have a strategy type. So we are using a strategy rolling update here, and we are selecting that. It's also the default. So you can see default is rolling update. And then under strategy.rollingUpdate, we have some other things that we can customize. We're going to do maxSurge and maxUnavailable. So these are the upper and lower boundaries, or that wiggle room that we're allowing during the update. maxSurge, that's the maximum number of pods that can be scheduled above the desired number of pods. It can be either an absolute number or a percentage. So let's go ahead and let's do 1, which is 20% of 5. And then maxUnavailable down here, the maximum number of pods that can be unavailable during the update. So we'll do 20%, which is another cute way to go ahead and say 1. So we're doing both approaches here and ensuring that we do have that, again, that wiggle room during the update. Let's go ahead and apply this, and then we'll see what's going on. Apply Kubernetes rolling updates, and I'm going to apply it into the default namespace for demo purposes just to make life easier. Gotta suggest that it's a file. So both of these were created. Let's go ahead and check on the deployments. Deployments. Excellent. The deployment demo, I have that 3 of 5 already. It's deploying the rest of that for me. And let's go ahead and check the replica sets. So you get replica sets. Or to make it easier, because if you can't spell like me, you can get RS. And you can see I have the replica sets also. Very, very cool stuff. I have the deployment name that we'll notice, so good old deployment demo. And then I have this random string here. This string has been added, and it is the pod template hash. Let's see what that is in the docs. So I have the pod template hash information over here. We can see that it is randomly generated, and the key language is this label ensures that the child replica sets of a deployment do not overlap. So that's good to know, and that's why they have that. Now let's get into that replica set, and let's see the YAML. We'll pipe it into a file, and we'll pull it up in the IDE over there. So get replica sets, YAML, and we'll put it in Kubernetes rolling ReplicaSet.yaml. And let's pull this thing up over here. Pull up. Really just a few things I wanted to call out. First, in the metadata, you can see some of these annotations. So the one that I want to draw attention to is the deployment, the revision. We are revision 1. That's going to be a good thing to note for later. And then we can also see the pod template hash is listed and some of the other metadata that we do have. So this isn't added to the labels that we had already created. And if we also want to take a look at the pod, we can run another command. So let's do get pods, get a name of one. Great, I have one. And then describe pods. Describe this thing. Whoa, a lot of things here. One thing I do want to call out, this controlled by. We can see, you know what? It is that daggum replica set, the one that was managing these pods. So this is as the owner, that's the dog tag right there. And then also a dog tag over here with the owner references as well. So really cool. That's fantastic, but that's the first update. We've only done a single deployment. Let's go ahead and apply another update and see how things change. So up to now, we've only seen a single deployment. We've only done a single deployment. We're on that first revision. Let's go ahead and apply an update and see how things change. So let me change a couple things. I'll change the version here. We're at V2. We're moving on up. V2, and then I'm going to change this to V2. Or this is like a Semver, not would be V2. It's a minor update, but it's just it's a new update that we're rolling out. So that's all that's really important there. Change the image tag, and I'm gonna hit a command quickly, and then we'll see the status as it happens. So let's run first. Let's do apply Kubernetes rolling updates, and then we'll string this command together. ctl rollout status deployment demo, then it's going to do exactly what it says it's going to do. It's going to show the rollout status, and we're going to see this in action. So we see that the update did get applied. This is configured. And then it's rolling out the replica sets, rolling this out, the deployment to finish. It's going to roll down here, but it's really cool to actually see those replicas in action. And wow, that was actually already finished up. I'll move my head, and we can see that it was successfully rolled out. So really cool to actually see that going on. Let's go ahead and get the replica sets now. So get replica sets. So we see we have two different replica sets here. One has a desired state of 5, and then the other has a desired state of 0. So the desired state of 5 is the new one. So why is that 0 there? Great question. I'm so glad you asked. That's in case we need to roll back to another prior state. Let's say there's something that we find in this deployment after it's out. It just isn't right, and we need to undo it. Well, there's a built-in way to do this. We'll cover that in another video. But for now, just know that it's the reason it's set up like this. And then let's go ahead and see. Kubectl, get replica set, the name of this new replica set. And then we'll just run the output YAML and take a look. So we are seeing, wow, now we can see the revision number is 2. So we are on the second revision. We're going into the replica set again. That's been incremented. So we know we're on the new version. That is really cool. So that's really it. We did a rolling update. If you have any questions or comments, please chime in the comments section. If you like this, please like and subscribe. Thanks very much for joining along, and I will see you the next time.